Hey guys. All right, we're going to learn a different kind of integration technique called U substitution. Now, you probably did U substitution in Calculus 1, but you probably didn't do a lot of it because it can be totally avoided in Cal 1, but it cannot be totally avoided in Cal 2. So in this video, I'm going to show you how to do U substitution. In the next video that you're going to watch after this, I'm going to show you how you can avoid it a lot of the time, but you can't always avoid it. So you need to watch this video and then go do the section that goes with U substitution. I'll show you in your Moodle homework assignments, okay? Then go watch the second video for Tuesday after you've done all that homework. Does that make sense? So you're gonna have kind of two videos and two different problem sets of homework for Tuesday night. Then when you come to class on Zoom on Thursday, we'll go over those homeworks. And then I'll show you another kind of another kind of integration technique. Okay, so this was called U substitution. So what I'm going to do is, hopefully, I'm going to share my screen and pull up a PowerPoint and kind of talk you through the PowerPoint. Okay, let me show you why you need U substitution sometimes. Now, I've given you problems like this before. You integrate 2x plus 3 squared. But the only way you know how to do that right now with what I've taught you is you'd have to multiply it out. So you'd have to go over here and do 2x plus 3 times 2x plus 3, and that would give you 4x squared plus 12x plus 9. And then, you can separate those and do just the 4x squared and the 12x and the 9. Remember, you can pull numbers in front. So if I pull that 4 in front, I'm integrating just x squared, and that's going to be my power rule. If I pull that 12 in front, then I'm just integrating x, and again, that's my power rule. And when I pull that 9 in front, then I'm integrating dx, and that's what I'm supposed to have memorized. Remember what your power rule says. You add 1 to your exponent, so 2 plus 1 is 3, then you got to divide by that same power. Remember, you have to keep that 4 that was in the front. So that 12 in the front comes down, and then remember, when there's not a power showing, it's understood to be a 1. Okay, whoops, let's clear that. Okay, so remember, that's a 1. All right, it's not doing very well right now. All right, we'll fix it in a minute. Okay, so it's a 1 right there. Okay, so remember, that's a 1, and 1 plus 1 is 2, and then divided by 2, and then when you integrate dx, remember, you just get x back. All right, so that'd be 4x cubed over 3, because remember, single things are just going to go over 1. All right, so I'd get 4x cubed over 3. Well, 12x squared divided by 2 is just 6x squared, and then 9x plus c. So I can work this one with, just regularly. But what if instead that 2 was a 12? I mean, does anybody want to say 2x plus 3 times itself 12 times and then multiply all that out and get this long, long giant polynomial and do it like this? See, I didn't think so. So this is what I would do instead. Now, this is kind of Dr. Gann's way of saying it. Okay? Now, I'm integrating a 2x plus 3 to the 12th, so that you can't really see that very well. Okay? So what I'm going to do is this. And here's what I mean by become your own fairy godmother. When I glance at that, what I think is, I wish it was just a single letter to a power. Okay? So that's what I mean by make your own wish come true. What could you substitute in for U and make it just a single letter raised to a power? All right. So to me, I see something raised to the 12th power. So I let U be my something. See, if I let U be 2x plus 3, I can replace this whole 2x plus 3 with this U. So I just have U to the 12th. All right. So all I did was take out 2x plus 3 and put in U, okay? But you cannot mix variables. You couldn't have the integration of U to the 12th dx. So if one thing changes to U, everything's got to change to U. Well, how do you do that? You do what you should have learned at the end of Cal 1 last semester or whenever you took it, and you should find the differential. Now remember what that is. Remember, the differential of something is its derivative with d and that variable next to it. So I've got to do the differential of u. So first I've got to do the derivative of u. So what's the derivative of 2x plus 3? Remember, the derivative of 2x is 2. The derivative of 3 is 0. So 2x plus 0 is 2, but then you have to add that dx. So the derivative with d and that letter right next to it. Now, I just have a dx, so I solved this for dx. So dx, if I divide both sides by 2, is just du over 2 or 1/2 du, depending on which way you like to write it. So this 2x plus 3 was replaced with this u, and this dx was replaced with du over 2. So now I've got everything's in terms of u's. Now remember, I won't always write it out, but I wrote it to make sure you understand. Du divided by 2 is the same thing as 1/2 times du. And see, I don't really need this number. So remember what we said we can do with numbers. If we want to, we can pull them out front. So that's what I did. I pulled that 1/2 out front. So I just had u to the 12th du. So I made my own wish come true. Okay. So now I've just got a letter to a power. So I know my power rule says your power goes up by 1. So 12 plus 1 is 13, and I divide by that 13. So I get u to the 13th over 26 plus c. But now, if I handed that back to my boss and he gave me this problem, he or she'd be confused because suddenly I've got u's and they gave me x's. So your last step is to substitute back. What was u really? Remember, u was 2x plus 3. So in place of that u, I went back and put 2x plus 3 to the 13th over 26 plus c. So this is my answer. Okay, so pause the video and copy these steps down and make sure you copy this example down. So look what your steps are. You've got to decide what you want to let u equal. And you be your own fairy godmother. Remember, you're trying to make your problem fit one of the forms on page 286. Okay, so you try to think of something you can let u equal to do that. All right, once you get your u, then you have to find du. And that's going to be the derivative of that u with d and that letter next to it. So the derivative of this thing, come on. And then d and that letter, my letter was x, so that's why it was dx. If that letter was z, it would be dz. Okay, and then you integrate, but your last step is to substitute your u back. Okay, so now let's go look at some more. All right, look at this one. Now, I know, again, what do I wish I had? Okay, what I wish I had was just cosine x, just cosine in a single letter. If it was just cosine z or cosine y or cosine x, I would know what to do because that's one I have memorized. So I wish I had a single letter for my angle. So that's what I do. I see the cosine of some angle. So I go let u be my some angle. Okay. So I see the cosine of something, so I let u be my something. So then I'm going to take this 5x out. Okay. And I'm going to replace it with my u. See, there's my u. So now I have cosine u. Well, I can't put dx there because I can't mix u's and x's. So remember, your next step was after you found d, after you decided u, you have to find the differential of u. So you take the derivative. So the derivative of 5x is just 5. And then you put d and that x next to it. But now notice what you've got. You just got a dx. You don't have a 5 dx. So I solved for dx by dividing both sides by 5. So that's where I get 1/5 du, or you can put du over 5 if that makes better sense to you. So this dx gets replaced with this 1/5 du, and that 5x got replaced with u. So remember, I replaced that one and I replaced that one. Now, I don't need this number, this 1/5. So numbers that you don't need can be pulled out front. You can't pull variables, but you can pull numbers. So I pulled that 1/5 out front. So that just left me cosine of u du, cosine of a single letter. Well, I've got that memorized. When you integrate cosine u, you should get sine u. The angles are the same. But remember, your last step is to substitute back what was u really. So u was really 5x. So I took out u and I put 5x in place of it. Okay, so look at this one. Now, we don't have any rules yet about roots. So far, we've always changed roots to powers. So that's the first thing I did, was I changed that root to a power. Now, here's what you cannot do. You cannot multiply out and distribute that x, because then you're not following your order of operations. You have to do powers before you multiply. So I can't distribute, all right? So I'm stuck. Now, when I look at this, here's what I notice. I've got a bunch of junk, but I've got something to a power. So when I've got something to a power, like a whole expression to a power, I usually let u be the inside of that. So I let u be 6x squared plus 4. Okay, so what am I going to do? Well, here's the deal. So that 6x squared plus 4 is going to turn into a u. So I'm going to have u to the 1/2. So that's where that u to the 1/2 came from. Now I just changed the order right here so you could follow my work over here a little bit easier. All right, so I just changed to put that first and that second. And you know, 2 times 3 and 3 times 2 are the same thing. So you can change the order on multiplication by the commutative property of multiplication. All right, so now I've turned that into u to the 1/2. But see, I've still got to worry about this x dx. I can't mix x's and u's. So I go over here. Remember, my second step is to do my differential. So what's the derivative of 6x squared plus 4? Getting the derivative 12x. And then I have to put that d and that x for my differential. Now look what I need. I need to replace x dx with something. So I just solved for x dx by dividing both sides by 12. So x times dx is du over 12. So in place of x dx, I put du over 12. So now do you see I only have u's? Now remember, numbers can be pulled out front. So I pulled that 12 out front, but notice it's on the bottom. So it's the denominator. So it's 1/12. That leaves me the u to the 1/2 and the du. So it's just power rule. So what do you do with powers? Don't you add 1? Well, 1/2 plus 1 is 3/2. Now, what's the same thing as dividing by 3/2? Multiplying by 2/3. So I just clean this up. 2 over 36 will reduce to 1/18. So I've got 1/18 u to the 3/2 plus c. And then your last step is to go back and take that u out and put what it really was to start with. U was really 6x squared plus 4. So the 1/18 stays the same, the 3/2 stays the same, the plus c stays the same. I just replaced my u with my 6x squared plus 4. Now, you're welcome to leave it like this for me, but sometimes in the back of the book, if they give you the problem as a root, they'll write the answer as a root. And I don't care, you can do it or not. But remember, if you change to a root, this denominator is your index number. So that's how I knew that that was a square root. And this numerator is the power inside. Okay, so let's go work some more and play with it a little bit more. All right, look at this one. All right, again, this just looks horrible. Now, I could multiply out the bottom, but I'd still be stuck, because I couldn't put x cubed over the first one and x cubed over the middle one and x cubed over the third one. That's not algebraically right. So I'm just stuck. I don't know what to do. But I do notice I've got something raised to a power. Now, before, remember, the only time that we had a fraction was when you had a 1 over a single letter. I don't have that. But I could take this and move it to the numerator. And remember, when you move something from bottom to top, the sign on that exponent changes. So that's the first thing I did, was I moved it up. Okay, now I don't know how to multiply out something to the -2. So I'm stuck again. So here's what I'm thinking. I notice I've got something to a power. So I decided to let u be the something. Okay, so I'm going to let u be the inside part. Okay, so that's why I let u be 1 plus x to the fourth. All right, then your second step is to find the differential. So the derivative of 1 is just 0, so it goes away, plus the derivative of x to the fourth is 4x cubed dx. Now notice what I'm going to do. I'm going to take out this 1 plus x to the fourth, and I'm going to put a u in place of it. So I'm going to have u to the negative 2. So that's where that u to the negative 2 came in. But I've still got to worry about this x cubed, and I've still got to worry about this dx. Now, again, I just rearranged the order and put them together because I noticed over here they were together. So I just solved for x cubed. So I solved for both of them at once. Now, you'll see a problem in a second where I can't do that. If I can, I do. So if I divide both sides by 4, x cubed dx is just du over 4. So I just replace this x cubed dx with du over 4. All right. And then I replace this 1 plus x to the fourth with u. Now again, I've got a number on the bottom and I don't need it, so I pulled it out, but it was 1/4, not 4, because that 4 is on the bottom of a fraction. So that left me u to the negative 2 over du. Okay, so remember what you do with powers, you add 1. Well, you know, a negative 2 plus 1 is a negative 1. So that's why it's u to the negative 1 divided by negative 1. Now remember, what's u to the negative 1? Now really, isn't it over a 1? Now remember what we can do. We can move things from top to bottom or bottom to top and change the sign on the power. So when I moved it down, that turns it into u to the positive 1. In other words, just 1 over u. And then when you divide something by a negative, it becomes a negative. So that's why that simplifies into that. And so I multiplied it out and got a negative 1 over 4u plus c. Remember, my last step is to substitute back. So I've got to take that u out, and in place, I've got to put that right there, that 1 plus x to the fourth. So that 1 plus x to the fourth. So that's why that's my final answer. Okay, so you kind of getting the hang of it a little bit. So you're still trying to make your answer fit one of those forms that you memorized. So when you have something to a power, let u be the inside. Okay. If you've got like a trig thing with an angle, you might want to let u be the angle. All right, look at this one. Okay. Now, the same kind of thing. See, I'm used to integrating e to the x. That's my favorite. But see, I don't have e to the x. I've got e to the 3x. So if it were e to a single letter, I would know what to do. So I become my own fairy godmother. I'm thinking, I wish it was just e to a single letter. Well, then do that. Make it, if u is 3x, then it is going to be e to a single letter, u. Then I've got to replace this dx. So again, I do the differential. The derivative of 3x is 3, and I've got to have that dx. And now, notice this time, I just need to replace dx. So I solve for dx by dividing by 3. So dx got replaced with du over 3, and 3x got replaced with u. And again, I didn't need this 1/3, this 3 on the bottom, so I pulled it out. So I've got e to the u. What happens when you integrate e to the single letter? Don't you just get e to that letter back? And then your last step, remember, is to substitute back. U is really 3x. Okay, so you're still trying to make it fit one of those forms. Now look at this one. Okay, now this is one of those, it's not hard, but it's a little longer, and here's why. Again, I change roots to powers because I don't have any formulas for roots. Okay, so that's what I did first. So I see something to a power. So I'm going to let u be the inside. So I'm going to let u be 2x plus 1. So that means so far, here's what I would have. I would have a u then to the 1/2. All right, but here's what I better not see you do on a test. Do you see I've still got this x to worry about? And I've still got this dx to worry about? All right, if you wrote this on your paper, I would count off. I do not want you mixing variables. So when you change one thing to U, everything's got to be turned into a U. So I did my differential. So the differential of U is the derivative. Well, that's 2, and that's dx. Well, see, I don't have an x and a dx. I just got a 2 and a dx. So when I solve for dx, in place of dx, I can put du over 2. So I can get rid of that. And right there, I can put du over 2. But do you see that I've still got a problem? I've still got this x. What am I going to do about it? I mean, I can't have x's and u's mixed up. So that 2x minus 1 got replaced with u to the 1/2. That dx got replaced with du over 2. But what am I going to do about this x? So I start looking to see if there's anywhere that I've got u's and x's together. Do you see right here that you've got u's and x's together? So I took that U substitution and I solved it for x. I added 1 to both sides, so that'd be U plus 1. I divided both sides by 2. So x can be replaced with U plus 1 over 2. So that's what I'm going to put in place of that x, U plus 1 over 2. So that 2x minus 1 got replaced with U. That x got replaced with U plus 1 over 2. And that dx got replaced with du over 2. So see, I either have x's or I have u's. I cannot mix them. Now, the first thing I would do is I don't need this 2 on the bottom or that 2 on the bottom. But really, because they're on the bottom, they're 1/2. So I pulled this 1/2 and put it there, and pulled that 1/2 and put it there, but I'm multiplying them, so that's where the 1/4 is going to come from. So that's going to leave me a u to the 1/2 and a u plus 1. Now here I can distribute. So what do you do with powers when you're multiplying? Don't you add them? And a 1 plus a 1/2 is a 1 and a 1/2 or a 3/2. And then u to the 1/2 times 1 is just u to the 1/2. So what I'm really going to do is I'm going to integrate that one plus, and then I'm going to integrate that one separately. So what happens to your power when you're integrating? Don't you add 1? Well, 3/2 plus 1 is 5/2. And dividing by 5/2 is the same thing as multiplying by 2/5. So plus, I add 1 to that. So 1 plus 1/2 is 3/2. And dividing by 3/2, same thing as multiplying by 2/3. But remember, I've got a 1/4 times all of that. So 2 times 1 is 2 over 20 will reduce to 1/10 u to the 5/2. And then 1/4 times 2/3 is going to be 2/12, which is going to reduce to 1/6 u to the 3/2 plus c. And then your last step is to substitute back. So I'm going to pull this u out, and I'm going to pull this u out, and I'm going to put in place of it 2x plus 1 in both places. So there's a 2x plus 1 to the 5/2. And a 2x, minus 1 to the 3/2. So your last step is to always substitute back. So with U substitution, what you're really doing is you're still trying to make it fit one of those forms on page 286. So if you've got an expression to a power, let U be the inside of that expression. All right. If you've got a trig word in front of an angle, if that angle is not a single letter, let U be that angle. If you've got E to an expression, let U be that expression. Okay, so you still got to use U substitution and make it fit that form. So what I want you to do, first of all, make sure that you pause this video and have all these examples in your notes so you can rewind and do that if you need to. Okay. Then make sure that you go back and work the homework that says you must use U substitution. After you've done that, then go watch the second video where I show you how to avoid U substitution if you want to. Now, some people use U substitution all the time in Cal 2. I don't, but some people do, okay? But sometimes everybody has to use it because sometimes you cannot avoid it. So that's why I need everybody to go work the problems using U substitution to make sure that if you have to use it, you can use it. Okay? Now, So are we clear? So you go to Moodle where homework assignments normally are at the top, and under February the 9th, you work the first ones that say must use U substitution. When you do that, then you go watch the second video about how to avoid U substitution. And then you go back to that same set of homework, and it's going to say work them any way you want to. So now you can use U substitution or not use U substitution, your choice. But both of those videos and both of those assignments have to be done before Thursday, okay? Because on Thursday, I'm going to put up another video, all right? If you need some help, you can always email me and ask for a one-on-one Zoom meeting, or you can snap a picture of your work and send it attached to an email, and I'll try to find your mistake and work it correctly and snap a picture and send it back, okay? But I will see you back in person next week. Hope you have a great day.